Okay, so this is just a quick tutorial showing off how you can use Rivet to improve your rigs. I have a pretty simple test rig here. It's just a cylinder with an IK spline on it, and it also has a single blend shape on it, which just makes it bulge in the middle. So some of you might have already seen Gio Coutinho's tutorial on the Rivet, but she doesn't go into detail on how the script works. And we're also going to do something extra in this tutorial that can help you on some rigs. So just like in her tutorial, we're going to select two sets of edges, only in this case we're not going to select just single edges, we're going to select an entire length of the cylinder. And then we're going to come up here to Modify, Convert Polygon Edges to Curves. We're going to take another set of edges right here, and we'll hit G to run the same command. Now we have two curves which are attached to the surface, and I will color them so you can see them. And no matter how we move the geometry, those two curves are always going to follow along with it. It's important not to delete history on these two curves because this poly edge to curve node is what allows them to update when you update the shape of the geometry. So I'm just going to name these Rivet Curve 1 and Rivet Curve 2. And then what we're going to do is select both of them, come up here to Modeling, Surfaces, and Loft. So now we have a surface that is running between these two curves. And that surface is also going to follow along with the geometry, just like those curves do. So now we just need to attach this control to this point on the surface. In order to do that, we're going to create a follicle. So I already have a script that can create a follicle, but I'm going to walk through it manually. So we'll name this Rivet Surf, and we're going to bring this guy into the node editor. Then we will create a follicle node just by hitting tab and typing in follicle, and we will take the world space attribute off of the surface's shape node, and plug it into the follicle shape. Make sure non-keyable is on, into input surface, because that tells the follicle which surface to attach itself to. Then we're going to take the out rotate and plug it into this transform node, and the out translate and plug it into the translate node. And now you can see that this follicle is attached to the surface, but it's attached over here on the corner, but we want it over here in the middle. So I'm just going to click on the follicle, come over here to the follicle shape in the channel box, type in 0.5 for the parameter u, which just means how far along the length of the surface it is, and then 0.5 on parameter v, which is how far along the width of the surface it is. Now we're going to create a locator and parent constrain it to the follicle. And I'm going to do maintain offset off so the locator is automatically moved into the position that we want. And again, I will color it just so we can see it more clearly. So now, whichever way I move the geometry, that locator is attached at that point. All we need to do now is select the locator and select this buffer group above the control that I've created, and go to constrain parent, and this time we want maintain offset on, and hit apply. Now that control will follow along with the geometry no matter which way we move it. And in addition, we could get into a pose and then use this control to kind of offset from it, because this control still works completely by itself. But there's one more thing that we could do. Let's say, for example, we wanted the control to slide along the surface no matter what shape the geometry was in. To do that, we would just need to change this parameter u value, right? So what we're going to do is we're going to connect an attribute on the control into that parameter u value. So we're going to click on the follicle, and we'll have to hit down on the arrow keys to select the follicle shape. So now you can see a different set of attributes showed up in the connection editor. Then we'll select the sphere surface control, load it over here, and I've already created an attribute which runs from 0 to 1 with a default value of 0.5, and we'll plug that in to parameter u. And now, when I change that value, the control slides along the surface. And that's not all that impressive when it's in this kind of pose, but let's say, for example, I've lifted this up into an S, and I've twisted it 180 degrees. Now when I hit slide, that control slides along the entire surface. Now there's one more thing that we have to cover, and that's global scale, because of course you want to put this in an actual rig. Oh, actually we've got one more thing. So we had that blend shape that we didn't really talk about that much, but that blend shape will also work with this rivet, because you can see it affects the curves, which affects the surface, which affects the follicle, and finally puts the control in the right spot. But let's talk about the global scale. So right now when I global scale, things are kind of falling apart. And so we can take a look at why that is happening. So first of all, this locator needs to be up here inside of the placement control, because it needs to get scaled up. So let's try global scale now. So now everything looks hunky-dory. But we still have all of this stuff that is outside of the hierarchy, and we want it inside of it. Now if you were to take these curves and move them up here to, let's say, the control group, and then global scale, the curves are getting double translated. I'm sorry, double transformed. So what we need to do is take those two rivet curves and move them into the do not touch group. The difference between the control group and the do not touch group is that the do not touch group has inherit transforms off. So even though in the outliner the do not touch group is a child of placement control, it isn't affected by the scale on that group. So same thing for the rivet surface, we got to move it into the do not touch group. The follicle is a little bit harder to understand, but I will show you what it looks like if we move it into the control group. And you can see that things have, oh no, I moved the wrong thing. Take the rivet follicle, move it into the control group. Now when I do global scale, you can see that things have kind of broken. That follicle is being double transformed. And the reason that that is happening is because the connections right here, the out translate and out rotate, on the follicle shape node, it finds the rotate and translate as if the follicle were in world space. But if we were to move it underneath the control group, it would be in a scaled up space. So that's why it breaks whenever global scale is more than 1. So all we need to do is take the rivet follicle and move it to the do not touch group. And now, when we global scale, everything is hunky-dory.